Welcome back to the Deep Dive. Today, we're going deep into something that's causing a lot of stress across some really high-stakes industries.
We're talking about this collision point.
Exactly. The collision between, sophisticated, modern artificial intelligence and just decades of messy, unstructured, legacy technical documentation.
It really is the defining technical challenge right now. I mean, we've hit this point where the foundational data, the manuals, the job cards that keep planes in the air,
The stuff that actually runs the world.
right, it's just fundamentally incompatible with the AI systems that everyone is rushing to deploy.
Okay, let's unpack that right away.
Hmm.
We all know that old computing principle, GICO, garbage in, garbage out.
A classic.
But the theme that keeps coming up in our sources today is, well, it's a much more dangerous assumption. It's this catastrophic belief in, and I'm quoting here, garbage in, gospel out.
That phrase, it should be on a huge warning sign in every boardroom. I'm serious. Companies are spending astronomical sums on AI.
Millions, billions.
Billions. And they're expecting these algorithms to perform some kind of linguistic alchemy. They think that AI will just magically transform their ambiguous, human-written prose, the garbage,
Yeah.
into perfect, authoritative, and, this is the critical part, safe operational results. The gospel.
But the input, that foundational data, it's
Mhm.
still the same old garbage.
Exactly. And that's the dangerous assumption, that the AI will somehow just resolve all the ambiguity from decades of, let's be honest, casual technical writing.
But it doesn't.
The sources are crystal clear on this. AI doesn't eliminate messy data, it just stales the uncertainty. So the same flawed sentence that makes a human technician pause and scratch their head today, that's what leads to a catastrophic and very subtle algorithmic error tomorrow, often with absolutely zero warning.
So it really forces a huge question. Is your organization building what the sources call semantic order, or are you just sort of preparing for smart chaos?
That's the choice.
Our mission today is to debunk that myth, that AI can handle ambiguity and to lay out the steps you need to take to future-proof your operations.
And it starts with understanding how the machine actually sees language.
This is where it gets really fascinating for me. Why is our normal, rich, standard English, the way you and I are talking right now, why is that considered noise to an LLM?
We have to completely shift our perspective. We have to look at it mathematically.
Okay.
For an LLM, language is not poetry, it's not prose, it's just advanced math, dealing entirely in probabilities.
Right. It's looking for patterns.
Always. Just statistical patterns. And standard English is just riddled with what the model sees as noise. Synonyms, complex sentences, passive voice, it all just obscures the core action.
The sources had a great example of that.
They did. Let's take that one. An engineer writes 3 slightly different things, all for the same task. One says, ensure the valve is checked.
Okay, simple enough.
Another one says, validation of the valve is required. And a third says, look over the valve conditions. Now, to a human, those are all just simple variations.
And we instantly know what to do. Check the valve.
Right. But to the machine, those are 3 completely distinct statistical patterns. Each one pulls the model down a different probability pathway.
So when it tries to combine them or create a new instruction from them.
The confidence score just plummets. And low confidence is the trigger for huge risks. First, the model might just default to a less than optimal instruction.
Or worse.
Or worse, it dramatically increases the risk of a hallucination, a subtle but potentially very dangerous error in the final output.
And that connects directly to the money. We're talking about safety, which is paramount. But
Yeah.
let's talk about the dollars and cents. The sources call it the token economy.
Yes.
LLMs charged by the token, right? These tiny pieces of data they process.
Precisely. And that verbose standard English isn't just risky, it is financially punishing. The more unstructured, the more wordy your input is, the more tokens the AI has to consume.
Give us that contrast from the source material again. It was pretty stark.
It's a great example. A legacy document might say, it is recommended that the user ensures the application of the brakes. That's 13 words.
All right.
A clean, structured language version. Apply the brakes.
3 words.
Just words.
That's a huge efficiency gain on just one single line.
Yeah.
But, I mean, let's play devil's advocate here. Why do a few extra words matter when you're dealing with millions of documents?
Because that inefficiency compounds exponentially. Every single one of those unnecessary tokens adds to the computational load during training.
Which costs a ton of money and energy.
A huge amount. But more importantly, it impacts real-time use on the shop floor. Longer, noisier inputs mean slower processing times and higher operational costs every single time that model is used.
Wow.
The sources confirm it. Adopting a controlled language can reduce your documentation volume and therefore your token consumption by an average of 30 to 40%.
So cleaning up the language isn't just a safety thing. It's probably the most direct way to slash the cost of your future AI rollout.
It absolutely is.
So if standard English is so risky and expensive, is there a standard solution out there? Something that actually solves this problem?
There is. And this brings us directly to the international standard known as ASD EASD 100.
Or simplified technical English?
Simplified technical English. And this isn't some new, untested idea.
Right, this has been around for a while, hasn't it?
For decades. STE was developed by the big players in aerospace and defense. We're talking Airbus, Boeing, NATO. They created it specifically to make sure critical procedures were universally understood.
Especially by non-native English speakers.
Exactly. People working on very high-value, very dangerous equipment. It is, by definition, clean, standardized input data. Its entire purpose is to eliminate ambiguity.
Which, as you said, is the root cause of the risk.
It's the primary source of both human error and algorithmic error.
So how does it do that? What are the actual rules that enforce that kind of cleanliness?
It uses a very rigorous, systematic set of rules. The most important one is the restricted vocabulary.
One word, one meaning.
One word, one meaning. Think about the word set. In normal English, set can mean to adjust something, to fix it in place. It can mean a collection of things.
Or like a stage set, at least 4 different meanings.
4 different probability pathways for the machine to get lost in. So if an engineer writes set the lever, the AI has to guess. But in STE, the word set might only be allowed to mean adjust. Confusion gone.
Instantly.
Instantly. Then you have rules like simple grammar and short sentences. Instructional steps are capped at a maximum of 20 words. No more complex dependent clauses where someone could miss a critical step.
Or where the machine misinterprets the sequence of events.
That's the key.
This precision obviously links straight back to safety and efficiency in places like MRO and maintenance, repair, and overhaul.
Of course.
But I have to ask, for an organization that's used to the flexibility of normal English, isn't this really restrictive? Doesn't it slow down the actual writing process?
That is the common pushback, you're right. But the sources show that the short-term friction is just. It's completely outweighed by the long-term gains.
There's a learning curve, I imagine.
Of course, but the operational benefits are immediate. For the technicians on the floor, STE eliminates what the sources call interpretation time. They're not pausing to translate a weird phrase or asking a supervisor for clarification.
Which means less rework from misunderstandings.
And crucially, it ensures the original intent from the OEM manual is perfectly preserved in the job cards.
And that reduces the burden on the certifying engineer.
An immense burden. The person who has to sign off on a return to service can do so knowing every single instruction was clear and unambiguous.
That makes everything safer and faster. So, who's responsible for this? This whole conversation really elevates the role of the technical writer. It's not just about writing anymore.
No.
This kind of linguistic precision is now, it has to be seen as data governance.
This is the profound paradigm shift that's happening. Organizations have to rethink their talent. A technical writer who is trained in STE is no longer just a writer.
They're what did the source call it?
A data architect.
A data architect. Explain that transition. How does a writer become an architect?
Because they are no longer just describing a procedure for a human to read. They are actively coding the logic of human language so that machines, which are now the primary consumers of this data, can understand and execute it.
So, every sentence in a maintenance manual becomes a line of code.
That's a perfect way to put it. It programs both human behavior and machine behavior. When you standardize a term in STE, you're creating a data node the AI can access with 100% confidence.
And if you allow 5 synonyms for that term,
you're creating data silos and confusion. The technical writer is now the person who ensures the input data structure can support reliable AI output. It's a critical role.
Which makes this all feel incredibly urgent. Why is cleaning up this legacy data so important right now? Because everyone is focused on the big, sexy future stuff, you know? The smart factory, the digital twin.
And that leads us to the central, most authoritative conclusion from all this research.
Which is?
You cannot build a smart factory or integrate a digital twin if your foundational data is dumb, if it's ambiguous.
If the instructions on how to maintain a physical turbine are vague.
Then the digital model of that turbine will also be vague, inaccurate, and ultimately useless. Or worse, dangerous.
So the lesson is that STE isn't just some best practice for the future.
No, it's the essential prerequisite. It has to happen before you spend a single dime on the advanced AI tool.
The clock is ticking.
It absolutely is. That technical debt, that giant mountain of unstructured documentation, the cost of it multiplies the second you deploy AI on top of it. You're basically paying millions to amplify confusion and scale your risk.
So organizations really have a choice to make.
They do. Are you investing in semantic order, which gives you clean, reliable data, or are you just blindly preparing for smart chaos?
And that kind of precision, you can't just bolt it on later as an afterthought.
No way. It requires a fundamental shift
Mhm.
and the expertise to guide a massive organization through that transition from legacy docs to a streamlined STE workflow that's highly specialized.
So for any organization listening that wants to build this foundation, the sources strongly recommend an expert resource.
They do. Shufrans Tech
And
Docs.
they stand out. Why?
They are seen as a global authority on ASD STE 100 implementation. And this is key. They have over 44 years of experience doing this in the toughest sectors: aerospace, defense, heavy machinery. This isn't theory for them.
It's proven application in the real world.
Exactly. And their focus isn't just on compliance, it's on mastery. I love this detail. Their expert training workshops are capped at just 5 participants.
Wow, 5. That's tiny.
It ensures maximum quality. It ensures mastery of this precision. They really are the go-to resource for teams needing to make this critical foundational shift.
So we'll leave you with this final thought. If the AI you're building is supposed to be the brain of your future operations,
Then you have to feed it structured, reliable language that eliminates all doubt.
because in the end, clean data isn't a luxury. It's the ultimate safety metric. We hope this deep dive helps you start those foundational conversations.